Today we are going to go over the second part of 8.2. In the first part, we learned the telescoping series and geometric series and also definition of convergence of series. In this lesson, 8.2 part 2, we are going to go over the nth term test for divergence. Okay, this is a very important and useful test, but it's test for divergence only. So what is the test? If the sigma n goes to 1 from infinity, a of n converges, we know the limit a of n has to be 0. But if limit a of n goes to 0 doesn't mean the sigma, the series, will converge. Okay, in this case, it's inclusive. However, if we know the limit of a of n is not 0, that means the nth term of this sequence is not 0. In this case, our conclusion is the series will diverge. This is what we call the nth term test for divergence. Let me show you some examples. So given this example, this is our an. As we know, as n goes to infinity, 2 of n goes to infinity, which is not 0. Okay, so directly we know the series will diverge. Because an is infinity, so it's not a number, also we know the sequence also diverges. And if you look at example 2, as n go to infinity, n over n plus 1 goes to 1. This 1 is not 0. Okay, so the series will diverge. However, the sequence itself converges, right? Because the nth term is a constant. Similarly, the limit n goes to infinity, n factorial over 2n factorial plus 1. As n go to infinity, this term is huge compared with 1. We can ignore 1. So the limit will be the same thing as n factorial over 2 times n factorial, which is 1/2. 1/2 is not 0, so the series, based on the nth term test, the series diverges. Because nth term equals a number, the sequence itself will converge.